In this video, we're going to have a look at how we can split a list in F# based on some predicate function. So scenarios like this, where we want to manipulate, for example, a list using other functions, is where F# gets really powerful. We're going to see that there's a lot of flexibility in the kind of approach you could take here, and it would be a bit more difficult to implement this in C#. So to illustrate the functionality, we're going to create a function called split_list. And the idea here is that we provide some predicate function. So this function would be applied to each element and say, let's say true or false, whether or not it fulfills some criteria. And depending on the output of that criteria, we would group our original list into two different lists, one containing the ones that are true, let's say, when we apply the predicate, and the ones that are false. So the signature of this function would be something like that. We give it a list and we give it a predicate function. And in here, we want to make use of the list.fold function. And I made a video on the array.fold function, and for lists, it works exactly the same way. So please check that one out if you haven't seen it. There's a link in the description. But we're going to apply this to some function. We haven't defined this yet, but we're going to say my function here. And this will alter our state. And the state that we have is a set of two lists, and we're going to start with these being empty, and then we're going to provide it the list parameter here. So if you recall from the array.fold functionality, what we do when we do this or apply this function is we provide it some function that's going to manipulate a starting state, and it's going to do that by iterating over all the elements in the list. So we're saying here we start with two empty lists like this. We're going to give it an input list, and this list.fold function will apply my function here that we haven't yet defined to each element of this list, and the state that is going to be updated over time starts to be two empty lists like this. That's what the functionality means. Now we need to implement the my function now, so let's do that. Let my function, and this one would then take as input the state that we have, and in this case that would be xs ys. So we're going to call, the lists, the two lists that we defined as our state down here, just xs and ys. And then we're also going to take the current element of this list that we're iterating over, and we're just going to call that x for now. And what is this function going to do? Well, it would check, and here's the nice thing about this. It would check if the predicate of x is true, and in that case, we would say that the state gets updated to append x to the xs list, and then we would just return the ys list as is. So we can apply this predicate function that we provide as an input to our split list function directly to x here. We don't need to know anything about what this predicate function does. We just need to know that it can be applied to one of the elements of the list that we originally provided as input here. So then we can append this like so, and if the criteria is not fulfilled, so else, that is, if predicate x is not true, then what we're going to do is we're going to say xs stays the same, and we append the value x to our list ys, like that. And that now will be a fully functional way of applying this. The only thing we haven't provided yet is the predicate function, but that is something we would specify in the input argument to our split list function. So let's just define one of these. We're going to do a very simple predicate function in this case. Predicate n, and we're going to say if n modulus 2 is 0, then that's going to be satisfied. So what this tells us is the predicate now is whether or not the input that we provide is an odd or an even number. And you can see that this is now specified for integers, so we're going to have to provide an integer list. But in practice, you could do this for, or in theory, you could do this for any kind of list. So let's just define the output as well. Output would be split list, like that. We would provide it the predicate function, and then we would provide it some lists. So let's say 1 to 10, like that. And it's that simple to define the functionality that we have here. If I execute this now in F# Interactive, we're going to see what the output of applying this is. So we have a predicate now that looks for each element in this list ranging from 1 to 10, and if it's even, it should be put in one list. If it's odd, it should be put in the other list. Ah, well, I just forgot the equal sign. There we go. Okay, so let's apply this again. And then we can see that the output of this application is simply a split list like this. So the first output is all the even numbers, and the second one contains all the odd numbers. So you can see that this functionality is very extendable. I mean, if I do just a simple variation of this, I change it to 3 instead, and now apply all this stuff, you can see that we immediately get a split list based on that criteria. And this can be generalized, I mean, to not just apply to integer lists, but apply to any sort of criteria for other lists as well. And you can see here really the scalability and the flexibility of F# languages when it comes to these kinds of operations. If we were to do this in C#, you would probably use some form of looping system, and it would be a lot more intricate, sort of where you apply what and where the criteria sit. With F#, this becomes very clean and very generalizable to larger sets of functions. So I hope you enjoyed this. Please check out the next video and see you there.